Welcome to this deep dive into cloud computing. Today, we are going to unpack the concept of serverless computing, a highly transformative approach to building modern applications. Let's get started. Let's begin by defining serverless computing. Despite the name serverless, servers are still very much involved. The difference is that the cloud provider completely abstracts them away from you. You don't have to provision, manage, or patch any operating systems. This model, often called function as a service or FaaS, takes platform as a service a step further. You just write your application code, and the cloud provider handles the entire backend infrastructure deployment, scaling, and management. This allows developers to focus purely on business logic rather than infrastructure maintenance. Looking at the diagram, we see the traditional separation of concerns has shifted. The developer simply writes the code and hands it to the serverless platform. The platform itself then takes over, automatically provisioning the compute and storage resources needed to run that code. There is no manual intervention required to spin up servers or configure load balancers. Why are so many organizations adopting serverless? First and foremost, it completely eliminates infrastructure management. Your IT staff is freed from routine monitoring and maintenance, allowing them to focus on innovation. Secondly, serverless offers true elastic scalability. It automatically scales out to meet high demand and scales back in when traffic drops. Finally, the pricing model is a game changer. With serverless, you only pay for the exact milliseconds your code is running. If your function isn't triggered, you aren't paying for idle compute time. This makes it incredibly cost-effective. This flowchart breaks down the 4 core benefits of serverless computing. At the top, we have our main question, why serverless? Branching out, we see the elimination of infrastructure management, which feeds directly into faster time to market. On the right, automatic elastic scaling ensures performance, while pay-per-execution pricing guarantees you only pay for what you use. Together, these pillars create a highly agile and cost-effective development environment. To understand how serverless works, you have to understand event-driven architecture. Serverless code doesn't just run continuously in the background. Instead, it waits for a specific event or trigger to wake it up. This could be an HTTP request from a user, a scheduled timer, or a message arriving in a queue. When the event happens, the cloud platform instantly allocates the resources to run your code. Once the task is complete, the resources are immediately deallocated. Furthermore, serverless platforms use bindings to easily connect your code to other services, eliminating the need to write complex integration plumbing. Let's trace the lifecycle of a serverless function in this diagram. It all starts on the left with an event trigger, which wakes up the serverless function. While executing, the function might use an input binding to pull data from a database, process it, and use an output binding to send the result to a message queue. Once the execution is complete, the function returns to an idle state, consuming 0 resources until the next event occurs. When should you reach for serverless computing? It is absolutely ideal for workloads with variable or unpredictable traffic. Because it scales instantly, it handles sudden spikes effortlessly without requiring you to maintain idle servers just in case. It's also the perfect fit for microservices architectures, allowing you to build applications as small, independent functions. If you need to automate business processes, integrate with SaaS applications, or execute short-running tasks that finish in seconds, serverless is the way to go. It is less suited for long-running, continuous compute tasks where a dedicated server might be more economical. This decision tree provides a simple heuristic for choosing serverless. We ask, is the workload predictable? If it's spiky or unpredictable, serverless is the immediate answer. If it is constant, we then ask if the tasks are short-running. If yes, serverless is still a great fit. However, if the workload is both constant and involves long-running, continuous processes, traditional virtual machines or containers might be a more appropriate choice. Let's take a deep dive into the compute side of serverless using Azure Functions. Azure Functions allows you to write isolated pieces of logic functions without worrying about the application shell or infrastructure. You can write these functions in your preferred language, whether that's .NET, Python, Java, or JavaScript. By default, these functions are stateless, meaning they spin up, do their job, and forget everything once they finish. However, if you have complex workflows that require memory of past events, you can use durable functions. This feature introduces stateful orchestration to the serverless environment, tracking activity context across multiple function executions. In this diagram, we see the versatility of Azure Functions. On the left, various triggers like HTTP requests, timers, or messages initiate the function. Once triggered, the function routes to either a stateless execution for quick, independent tasks or a durable, stateful execution for complex, multi-step workflows that need to remember their progress. This shows how serverless can adapt to both simple and highly complex architectural needs. Serverless isn't just about executing code, it's also about orchestration and messaging. Azure Logic Apps provides a serverless way to automate business workflows. Instead of writing code, you use a visual designer to weave together API calls to hundreds of services like Office 365, Salesforce, and SAP. To connect all these discrete pieces, we use Azure Event Grid. Event Grid is a serverless event routing backbone. It captures events from various sources and securely delivers them to subscribers. Because it is serverless, it automatically scales to handle millions of events per second, perfectly decoupling your applications. This diagram illustrates serverless orchestration in action. An event source publishes an event into Azure Event Grid, which acts as the central router. Event Grid instantly routes this event to an Azure Logic app. The Logic app then takes over, executing a predefined workflow that triggers API calls to disparate SaaS platforms like Office 365 and Salesforce. The entire flow happens automatically, seamlessly, and without managing a single server. Let's look at a highly practical, real-world use case for serverless, automated order processing. Imagine a company that receives shipping orders via email. We can completely automate this using serverless architecture. First, an Azure Logic app is set up to listen to an Office 365 inbox. The moment an order email arrives, the Logic app is triggered. It automatically parses the email data and queries an Azure SQL database to verify inventory. Once confirmed, the Logic app uses a pre-built Twilio connector to instantly send an SMS text message to the customer's phone, notifying them that the item has shipped. The company pays only when an order is processed. This sequence diagram maps out the exact flow of our real-world use case. The process starts when an email hits Office 365, which immediately pushes a trigger to the Logic app. The Logic app then queries the SQL database. Once the database confirms the inventory, it replies to the Logic app. Finally, the Logic app reaches out to Twilio to dispatch the SMS notification. Every step is automated, serverless, and highly scalable. To summarize, serverless computing shifts the burden of infrastructure management to the cloud provider, giving you extreme agility and cost savings through a pay-per-execution model. To succeed with serverless, follow a few best practices. Keep your functions small, focused, and short-running, embracing a true microservices approach. Use asynchronous messaging tools like Azure Event Grid or Service Bus to decouple your architecture, ensuring that a failure in one component doesn't bring down the whole system. Finally, always monitor your serverless apps. Tools like Application Insights provide crucial visibility into performance anomalies and failures, keeping your serverless ecosystem healthy. Our final diagram is a mind map of serverless best practices. From the center, we branch out to 3 core tenets: keeping functions small, using asynchronous messaging, and monitoring with Application Insights. These practices directly lead to the desired outcomes shown at the bottom: a clean microservices architecture, perfectly decoupled systems, and ultimately, high reliability for your cloud-native applications.